Hi, my name is Keith Tenzer, and I'm so glad you've joined me today because together we are going to discover the art of possible with PrivateAI, where you control the AI and you don't have to share your data with the rest of the world. I want to talk about RAG, Retrieval Augmented Generation. And let's face it, it's had some problems of late. With context windows increasing, we can now upload literally encyclopedias of data to LLMs. Models are multimodal, they can understand images and text. And let's be honest, RAG never really did well with scientific data. It struggled mightily with formulas and with graphs and the like. And it was very complex. You had to write a bunch of code, you had to maintain vector databases, and you had to have pipelines for updating things. It wasn't all that easy. And finally, latency. All this retrieval does come at a cost. But is RAG truly dead, like so many people say? What if it wasn't dead? What if there was a better way to group data to where we can understand context of data better, understand relationships between images, formulas, graphs, and all the scientific data and all the text together? Well, then we could reason about it and make better discoveries and better answers to questions. So I say RAG is dead. Long live knowledge graph, which is a new way of doing retrieval augmented generation. We take the same OCR where we look at an image or document and pull it out and pull out the text and the context, and we vectorize it. However, where it's different is what we do with those vectors. Instead of just putting them into a vector database, we actually create a graph. And that graph, it represents nodes and edges that connect data together in very interesting ways and allow us to gather much better context and much clearer context so that the LLM can give a much more sophisticated and detailed answer to our questions. And so now let us look at this in action. We are going to see what we can do with open source models on WebAI running on my MacBook here against the mighty OpenAI O3 reasoning model, a model that has been built with trillions of parameters, a model that runs in server farms the size of a city, a model that is probably responsible for half of NVIDIA's stock gains over the course of the last year. It is truly a remarkable model. And this is a monumental challenge. And so let's have at it. All right, here we go. On the left, I have the mighty O3 from OpenAI, and you can see I've uploaded an image or a document here. And this document is a manual for mill operations. And it is a very beefy manual. As you can see here, it's hundreds of pages, and it's not the text, but there's lots of images. There's lots of understanding relational space and spatialness, and there's a lot of stuff here. And this is something that traditionally is very difficult to make sense of for an LLM. Of course, O3 will do a great job of this. We don't expect it to fall on its face. However, how will it compare to stuff running on my MacBook is the question. So we've loaded this up on the left with O3. On the right, we have WebAI's platform, which runs on Apple hardware and Apple Silicon. And you can see here, it's essentially a framework for building AI workflows. And this is just one of the things you can do. There's elements, which are these boxes you can drag and drop, and you can basically use these elements to create workflows. And so for this knowledge graph, there's basically two parts to it. One is ingestion, where I create the graph, which we're going to do together. So I'm going to create this document ingestion, and I'm going to show you here in the settings And we're going to only need to do two things. We're going to need to point this at where our data is right here. So this is our document that we want to ingest, this massive manual. And where we're going to output the processed artifacts from that document. So that's already been done. And then in the knowledge graph builder over here, we're going to point it at the input, which is the things we've processed from ingestion, which is basically our OCR, and the output, which is our graph. And so I'm just going to run this, and it's going to take a few minutes here, and we'll be right back when it's finished. All right, we are back just a few minutes later, and we have our knowledge graph. And so now I'm going to open it up, and we are going to see what this actually looks like, which is pretty interesting. It takes a few moments to load, but this is going to show us all of the things that are connected together, all of that data, all of that beautiful data. Look at that. Isn't that something? And you can dive in here and you can see, if you obviously go in a little bit closer and zoom in, and you can start to understand all the interlinking between the data that the knowledge graph built. This is so much more sophisticated than what we were doing with RAG and chunking with sentences. Even semantic chunking doesn't come close to this. So let's see how it performs. That is the question. Will it be on par with the mighty O3? So over here, I've built another workflow, and this has the API element, so we can expose actually the OpenAI chat completions API. We have a Llama 4 model here ready to go, and we have our knowledge graph. And all we had to do was just point it at the graph folder where we created the knowledge graph that we just looked at. So let's start this, and we can get going. I'm super excited to see what happens. We've got both chat windows going here, and now all we have to do is ask the questions. So I've got here a bunch of questions and answers. I've gone through the manual, I've read it, I've tried to understand certain things, and I've created questions, and I've found the answers to those. So let's start here with one of the easier questions, which is figuring out what the spindle speed is of this machine. Should be a very easy question for ChatGPT to answer. It is a little tricky because in the manual it does say that it is machines between, I think, ST30 and 35. So it's a little bit tricky, but it shouldn't be any problem whatsoever. And you can see ChatGPT is going here, O3 is going, looking at the document, sifting through the information, and it found, in fact, that it was 1500 RPMs. This is actually information in a table, no big deal. They both nailed it, no problem. What is really interesting here with WebAI and what they've done is they're actually providing sources, so you can actually see where this data came from. So if I click on one of these links, you can see here, this is the page where, in fact, it's getting this information from this 1500 down here. So yes, very, very cool stuff indeed. Okay. Let's get on to some more interesting questions. So this question actually asks to describe what we are seeing on a picture. Describe what the power button looks like, essentially. This is a little bit of a tough question because it does involve spatial recognition, and it's going to be a challenge. Let's see how these models handle this. And the knowledge graph. You can see the knowledge graph already has its answer. ChatGPT is cranking away, O3 is cranking away, trying to get it. And it in fact says that it's associated is a vertical line, and the line is black. So it gives us a description of what we asked it for. We can look here at the link that it's given us, and you can actually see this is what we were asking is, what does this look like? And yeah, it's a black vertical line. Pretty good, pretty good. Let's see if here it is. O3 cannot figure it out. It doesn't know. It cannot reason with what that picture is. So there's 1.4 WebAI. Okay, that was cool. Let us look at some other things. This is more a information text-based answer or question regarding what is being displayed, but it's being displayed on a pop-up menu. So it's on an image. It's basically a table on an image. So again, this is a simple retrieval case, but the fact that it's on an image makes it a little bit of a challenge. Let's see how they handle it. And off we go. And O3 is cranking away, reading that document, trying to get the information. And here we have our answer: system data, user data, programs, offset, macros, ATM, and network. And if I, in fact, open up the link, you can see exactly those are the things that are part of this restore menu here, this restore machine pop-up. And we can see here, O3, it looks like, has missed a few things here. It has some of the data, but it has missed a few pieces. It has missed this macros option and thrown a couple extra ones in there. So not entirely correct at all. So that's another point for WebAI. And let's see now, let's ask our final question here, and then I'll show you all of the results. We're going to ask here, these machines, these spindles have programming models, and you can actually program these machines. And so I'm going to ask here how to do nested while loops in this language. And so this is also a bit of a tricky question because it does involve reading some text and also looking at tables to reference where those code examples are. And so let's see what comes back. We already have our answer from WebAI, and it comes back and it does look like it is correct. Yes, nesting while loops here. The key thing here to pay attention to is that there has to be this ID associated with these loops, this nested index, I'm sorry. And so here it is, this ID. That's how these while loops that you can nest them, that they know that it's part of the same construct. Okay, and O3 did look like it did a pretty good job here as well. Let me see, does it mention the index part of it? It doesn't mention specifically, it looks like, about the index, but overall it looks to be mostly right. Although the answer here from WebAI, I think, is a better one, right? For sure. Okay, so we saw some interesting questions here and how these two models reacted. Now let us look at the results for all of this. And so these were all the questions, and you can see here which ones on the left here is O3, the mighty O3, and on the right, WebAI with an open source model and this knowledge graph running on a MacBook. And you can see here pretty much WebAI nailed everything except for one question. It did get wrong. I gave it wrong. I asked a trick question here about a for loop. There is no such thing as a for loop. And it did notice, or it did tell me that it wasn't possible to determine this because, you know, they couldn't find anything about a for loop. However, it couldn't provide a definitive answer. And I suspect here, this is a little bit the difference Llama and Llama's ability to reason compared to the mighty O3, and not something on the knowledge graph. But nevertheless, it did get one question wrong. And so the end results here, we have 11 out of 20 for O3 and 19 out of 20 for an open source model running on a laptop with the knowledge graph, which I think shows how powerful this potentially is. Well, that was quite amazing, and I do hope you enjoyed this, and I really appreciate you for sticking around. You can find me, if you're interested, on YouTube at KeithTensor or KTensor, at GitHub keithtensor and keithtensor.com. Again, thank you. I'm going to be exploring much more, and I hope you'll join me looking at this exciting new space with private AI.